Hey guys, I'll be explaining about cellular transport today, and I'll be explaining the basic vocabulary and the necessary things you have to know. Let's get started. So, first of all, what is diffusion? Diffusion is the movement of molecules from a higher to a lower concentration. For example, this shows that the water molecules on the right have a higher concentration, and the water molecules inside the cell left has a lower concentration. See what happens. The water molecule with the higher concentration, which on the right, decides to equal out the concentration, therefore moving into the lower concentration. Basically meaning that whenever there's a higher concentration of a certain molecule, and on the opposite side there's a lower concentration, they try to balance it out. So, next step, what is osmosis? Osmosis is a diffusion of water molecules across a semi-permeable membrane. But wait! What in the world is a semi-permeable membrane, you ask? Good question. A semi-permeable membrane is a membrane that only allows some molecules to pass while blocking others out. What are the three parts of osmosis? The three parts of osmosis are also known as solutions. Since I've just said solution, you're probably wondering what it's about and what in the world it is. A solution is a substance with a solute dissolved in it. These solutions are called hypotonic, hypertonic, and isotonic. First of all, what is a hypotonic solution? A hypotonic solution has a high concentration of liquid and a low concentration of solute. As you see in the picture below, the high concentration of water, represented as blue, shows that it is much farther greater than the low concentration of salt, shown as the little white dots. Second, what is a hypertonic solution? A hypertonic solution has a high concentration of solute and a relevantly low concentration of liquid. As you see in the picture below, you can see that there's a high concentration of salt and a low concentration of water, relatively compared. Finally, what is an isotonic solution? Well, you guys might have guessed. An isotonic solution is one that has a balance of both solute and liquid concentrations. As you see in the picture below, there's equal amount of salt and there's an equal amount of water concentration. Examples of hypotonic, hypertonic, and isotonic. First of all, water will be representing liquid, salt will be representing solute, and the cell will be representing the semi-permeable membrane. So, let's get started. Hypotonic. The hypotonic solution has a high concentration of water and a low concentration of solute. Due to osmosis, the water outside flows inwards, and the salt molecules in the cell move outwards through diffusion. Therefore, the cell becomes plump and getting more volume. And as the cell gains more volume, see what happens. Pop. As the cell gets wider and wider, there's a certain point where it can't hold any more liquid inside, so it pops. Next, hypertonic. The hypertonic solution has a high concentration of solute and a low concentration of liquid. Due to osmosis, the salt outside flows inward and the water in the cell moves outward through diffusion. Therefore, the cell shrinks and loses volume. And see what happens as the cell continues to shrink. Boop. It disappears. Well, that's what you might think. But actually, it shrinks so much that it actually dies, represented as a cell. Next is isotonic. Isotonic has the same concentration of salt and water. Therefore, it stays the same. See what happens as time goes on. Exactly, nothing happens. Moving onwards, what is facilitated diffusion? Unlike normal diffusion, facilitated diffusion is a diffusion of larger molecules through channels in the cell membrane. Facilitated diffusion is an active transport costing ATP and using energy to function. As you see in this picture, you can see protein molecules going through channels, and the H2O molecules, represented for water, are going through the smaller channels. What is a sodium-potassium pump? Wow, that looks confusing, but it's not that hard. A sodium-potassium pump is literally what it stands for. It is a channel in the cell membrane that opens and allows sodium and potassium molecules to pass. As you see in the picture below, the channel kind of resembles a sodium-potassium pump. Here's kind of what it looks like. In the first top left, I represented Na plus and K plus. if you guys don't know what that is, the Na stands for potassium and the K represents sodium. As you guys see, the Na plus and the K plus have stayed outside of the channel, waiting for it to open. Later on, the channel opens, letting all the molecules in. After that, the bottom right, the molecules stay and move upwards or downwards through near the entrance, and later, bottom left, the molecules exit. What are other forms of active transport? Other forms of active transport are endocytosis and exocytosis. Endocytosis is a process where cells take in molecules by engulfing the particle. Exocytosis is a process where cells can expel waste or other molecules. Endocytosis and exocytosis. While endocytosis has two smaller parts to it, exocytosis does not. The two smaller parts of endocytosis is phagocytosis, when cells absorb large solid molecules through endocytosis, and pinocytosis, where cells absorb liquids through endocytosis. First of all, I'll be showing you guys a picture of the phagocytosis. As I've explained before, the molecule is being absorbed by the cell, and then it's being transported later on. Next is pinocytosis. The liquid, as it moves along, is captured by the cell, later being engulfed, and you could see the liquid is later on free to roam inside the cell. Next is exocytosis. It's a step where the cell throws away its waste. For example, first of all, there was liquid in the cell, but later on, the cell forms air bubbles, letting the liquid out / waste out. In conclusion, passive transport does not require energy and is the simplest type of diffusion. Facilitated transport does not require energy. It's a bit more complicated, but it's a very simple type of diffusion. Active transport requires ATP / energy, it's the most complicated type of diffusion, but all three of them is necessary and required for a cell to do what it does. Well, that's all you guys have to know. Thank you for listening. Goodbye.